the question is, how does boiling point or freezing point affect the dissolution of a solid in water, and what is its relevance to the different industries in our day-to-day lives? Well, to answer that question, let's break it down into more simpler terms. It's asking, what does the boiling point or freezing point do to the dissolution of a solid in water? Let's break down that sentence. What does dissolution mean? Well, it's defined as the process of being dissolved or dissolving. So what it's asking is, what happens to the boiling point or freezing point of water if a solid is being dissolved, if a solid is introduced? Well, pure water with nothing in it boils at around 100 degrees Celsius at 1 atm of pressure. But when anything is dissolved in the water, the solution will boil at a higher temperature than normal water would. For example, when you add salt into water, the resulting solution has a higher boiling point than if the water was boiled by itself. This is because the ions form an attraction with the solvent particles that prevents the water molecules going into a gas phase. Therefore, the saltwater solution will not boil at exactly 100 degrees Celsius. It needs to be a little higher than that. For the saltwater solution to be boiled, the temperature must be raised at about 100 degrees Celsius as well, so it becomes 200. This phenomenon is called boiling point elevation, and it happens whenever a solid is introduced into water as it boils. For every mole of particles dissolved in a liter of water, the boiling point increases by about 0.5 degrees Celsius. Because the presence of the solute particles decreases the vapor pressure of the liquid solvent, a higher temperature is needed to achieve a boiling point. Now, adding a solute to a solvent has an opposite effect on its freezing point. Solvent will have a lower freezing point than a pure solvent, and that is because the freezing point is at the temperature at which the liquid changes into a solid. If a substance is added to that solvent, the solute-solvent interactions will prevent the solvent from going into a solid phase, and that requires the solvent to be at a lower temperature to achieve its freezing point. This phenomenon is called freezing point depression. For every mole of particles in a liter of water, the freezing point decreases by about 1.9 degrees Celsius. A common example is when salt is used in roads before snowing. That is because when salt is applied to the icy roadways, the roads will not freeze at a normal 0 degrees Celsius. Instead, it will freeze at a much lower -9 degrees Celsius. And this is true for any solute that is added to a solvent. The freezing point of the solution will be lower than the freezing point of a pure solvent without the solute. Thus, when anything is dissolved in water, the solution will either freeze at a lower temperature or boil at a higher temperature than a pure solute would, aka just pure water would. And that is how the boiling point or freezing point is affected by the dissolution of a solid in water.
So that one may better understand how boiling points and freezing points affect the dissolution of solid water in our day-to-day lives, experiments that can be conducted at home with typical household items are the best to perform and observe. The materials that you are going to need are a variety of liquids such as water, juice, soda, oil, wax, chocolate, etc., a meat thermometer or a cooking thermometer, a small pot to use in the stove, and a freezer, and note-taking materials for recording observations such as notebook, pencil, phone, whatever. And here we have the steps to conducting this experiment. First of all, take note of each item state at room temperature. Second, place the different liquids and the thermometer in a freezer. Check every 10 minutes to see if it has solidified. Take note of the temperature of the liquids that have started to freeze. Step 3, Heat each liquid in the pot and wait for it to boil. When it starts boiling, take note of the liquid's temperature with the thermometer. And lastly, number 4, compile all records during the experiment and make a chart to properly organize and compare your observations of the different liquids' highest and lowest points for freezing and boiling.
The freezing point of solutions is relatively lower to the original pure solvent or solute, mainly because solutions tend to have high entropy when solute and solvent are mixed together. As liquids solidify, it creates order and the entropy decreases at the same time. Since the entropy is high, it takes more energy to decrease it to the same point. To simply put, if solutes are dissolved in a solvent, the solution will freeze at a lower temperature at which the vapor pressure of both solid and liquid are said to be at its equilibrium. However, in relation to the misconception about the limited solubility of solution, there are solutions that do not entirely freeze at a certain temperature. Needless to say, different solutions freeze at different temperatures. Some will freeze faster or slower, and some will not freeze at all. Some people believe that it's because there are yet solutes to be dissolved, when in fact, it just actively demonstrates the concept of limited solubility of a solution. It simply means that solutions have its maximum concentration of solute that may dissolve in a solvent to form a solution based on a certain temperature. In most cases, only a certain limited amount of solute can be dissolved in a given amount of solvent. Another misconception about the concept of solubility of a solution is that many believe that the solutes entirely disappear when dissolved in a solvent. But in actuality, the solutes just replace the water molecules to reach its equilibrium. Through our simple experiment, there will be a variety of liquids to be placed at freezer and pot to observe and record each of its freezing and boiling points, and also to replace the mentioned misconceptions with alternative narratives.
She shows makes me a go-getter. I haven't gone as far as asking if I could get with her. I just play love by ear and hope she gets the picture. I'm shooting for her heart, got my finger on the trigger. She can be my broad, and I can be her nigga, but